This is data analysis in a nutshell number 2. What do you do with all that raw data? And that's essentially what we're looking at now. The last part of our journey was this. You had to think about your independent variable that you were trying to find, that you had, and the dependent variable that you were trying to find to see if you could see a relationship. So in the osmosis prac, they had different concentrations of salt solution, and they were trying to see if that changed the mass of water that was absorbed and lost from the potato that was being soaked in it. And to get that, they had to have some raw data tables, because to find the change in mass, you actually have to measure the initial mass and the final mass to get to the change in mass. In other words, you have to have lots and lots of little pieces of data that you pull together to get to where you want to go. That's your raw data. Now we're going to look at how we actually make some meaning of that data. And the very first thing you need to do is to pull your data together to have a look at it. So for every group of independent variables that you have, so in this case they had 0% solution, 0.5, 1% solution, 2% solution, you want to group all that data together to see if you can see if you had repeatability, accuracy in your measurements. Okay, could you repeat that same trial for that same concentration over and over again and get roughly the same result if your method is accurate? So over here we have the 0% solution. We've taken all of our initial masses and final masses and changes in masses and put them into one little table here. And as you can see, we didn't have exactly the same initial mass to begin with, because when you try and cut a cube of potato, they're not all going to be exactly the same. So therefore, your final mass is going to be slightly different, and that's fine. We're not worried about that too much. Yes, the potato sizes are going to be slightly different, but when we compare its change in mass to what it originally was, how much variability did we get? So with these guys, they measured their changes of masses, but if you had a different initial mass to deal with, is that change in mass going to be easily comparable when you started with a different mass to begin with? As a pure number like this, no, you can't easily compare them because you had a different starting point. So what they did first was they started to look at, okay, I can't compare these numbers directly, but I can look at how much it changed compared to its initial average mass. And so what these guys did was they then turned this into a percent change, which basically compares the change in mass to its original amount, so that they can then compare these numbers and be happy with comparing them. So this first one, it changed by almost 19%. The second one, it changed by a factor of almost 11. So overall, over all those 10 trials, you can see that the percent change in the mass ranged from 3.8 up to almost 19%. Quite a lot of variability, would you say? We'll have a look at some of these others. Looking here, for this 1% solution, they went from like 0% up to 22. And this one here, they went from, this is funny, in some cases it decreased mass, and in other ones it increased mass up to 15%. So it literally shrunk and grew in this 2% trial, which is really weird. So they actually had even worse variability in this trial here, and so on and so forth. Really, if you're going to be putting something in a solution, you'd think it would either increase or decrease, not do both. But in fact, they actually had some measurements here where they showed that it increased instead of decreased. So they had a lot of variability in their data. And if they hadn't done 10 trials of everything, would they have been able to see that their data was in fact varying quite dramatically? Would they have known that they had a lot of error in there? The answer is no, they wouldn't have. If they hadn't have done a whole heap of trials, they wouldn't have known which parts of their data were wrong and which parts of their data were closer to the truth. So you have to have multiple trials. That's what it comes down to. You have to have multiple trials. Otherwise, you can't take that data further and you can't analyze how much error you have in your data. And if you are going to delete some of the data because you can see it's really way out there, well, you wouldn't know what to delete unless you had lots and lots of trials of data in order to know what should be the answer and what is most likely an error. And in this case here, I'm seeing all of these negatives where it's shrunk, and this positive here and this positive here. I'm thinking someone has written down some things incorrectly and that those two pieces of data are actually in error. And in my final analysis, I would actually tend to delete them because I don't trust those results. They are completely different to the rest of my 10 trials. So 8 of them went down, 2 of them went up. I would then actually delete this from the raw data, talking about it later in my evaluation, because to me, that is an error. Someone's written something down or measured it wrong. I shouldn't leave it in there for my comparison, or it's going to increase the error analysis in my data, and basically it makes my data unreliable. So, as you can see here, what they've done is they've not only pulled their results for every independent group, but they've then changed or made something more out of that data in order to get a better picture. Because in this case, because every initial mass is different, just looking at the change in mass doesn't help. But if we look at the percent change in mass, which compares the two, then that allows them to then compare all of these guys against themselves. So looking at the percent change might be a direction that you go. It all depends on your group and what you have to find. So that's the next thing. You need to group all your data into one table and make any calculations so that you can compare that data together. So here's a summary point on our data analysis in a nutshell journey. Gather each of your independent data groups together so you can compare them, and if you have different starting points, you need to manipulate that data so that you can compare them. So in this case, they worked out the percent change so that across each potato so that they can compare the original volume to the final volume. That meant they could compare the data across all of those trials regardless of their starting point. Now the next step that we're going to be doing in this is we're going to be looking at manipulating that data further and doing some statistical analysis to see how accurate it is before we make some judgment calls on it.